Hello dear students, welcome back to our YouTube channel. As you know that we are studying about the integral transform, in which we are studying about the inverse Laplace transform. In previous lecture we have seen two different chapters. First one is beta and gamma function and the second one is Laplace transform. We know that the definition and some basic formulas of beta and gamma function, different phases of beta and gamma function, and properties and theorems which are dependent upon beta and gamma function. After that we have learned in Laplace transform the definition of Laplace transform and some basic functions, Laplace transform of some basic functions and theorems and properties based on Laplace transform. And we know that why we are studying, because we convert differential equation into algebraic form by using Laplace transform. And whenever we come across a very complicated and complex differential equation, we use Laplace transform to convert that equation into algebraic form. And we know that so many methods to solve algebraic equation. After solving algebraic equation, we get answer in algebraic form. So we have question in differential form and answer is in algebraic form. So we use inverse Laplace transform to convert that algebraic result into another form and the form of differential equation. So today we are going to study theorem or inverse. Today we are going to start with example depend upon inverse Laplace transform. Now example is as follows. Evaluate inverse Laplace transform of 1 upon s raised to minus 4 raised to 5 plus 5 upon s minus 2 square plus 5 square. And today we are going to solve this example. We have example to find, evaluate an inverse, means inverse Laplace transform of 1 upon s minus 4 raised to 5 plus 5 upon s minus 2 square plus 5 square. Before going to start to solve this example, we must know how to solve this example. Since we have two functions which are connected by addition, so we know that the inverse Laplace transform of c1 f1 of s plus c2 f2 of s, so we get c1 inverse Laplace transform of s f1 of s plus c2 inverse Laplace transform of f2 of s. Now we have the linearity property in inverse Laplace transform, so we can distribute inverse Laplace transform operator to both functions. Correct? So we will get inverse Laplace transform of 1 upon s minus 4 raised to 5 plus inverse Laplace transform of 5 upon s minus 2 square plus 5 square. We have inverse Laplace transform of 1 upon s minus 4 bracket s to 5 plus 5 upon s minus 2 bracket square plus 5 what is the first shifting theorem is? The first shifting theorem tells us that is the inverse Laplace transform of f of s minus a will give us e raised to at inverse Laplace transform of f of a. We have already proved this theorem that inverse Laplace transform of f of s minus a is equal to e raised to at f of t. So using first shifting theorem here, inverse Laplace transform of 1 upon s minus 4 bracket raised to 5, and here also, so we can write this equation as e raised to 4t. Since if we have s minus a, we will get e raised to 18 positive, and when we have s plus a, we will get e raised to minus a. So remember, whenever we have minus sign, we will get e raised to in positive, and whenever we have s plus a, we will get e raised to minus 1. Correct? Now inverse Laplace transform of 1 upon s raised to 5 plus. Now we have s minus 2, so we can write it as e raised to 2t inverse Laplace transform of 5 upon s square plus 5 square. S square plus 5 square. Correct? Now we have some basic inverse Laplace transform, in which we have, since we have Laplace transform of t raised to n, we know that the Laplace transform of t raised to n is n factorial upon s raised to n plus 1. Correct? So t raised to n upon n factorial will give us inverse Laplace transform of 1 upon n plus. Is it correct? Yes. Now since we have inverse Laplace transform of sin at is equal to a upon s square plus a square. So inverse Laplace transform of a upon s square plus a square is equal to sin. Is it correct? Yes. Both formulae we have already studied and discussed in previous lecture. Now by using these formulae, we will try to solve this equation, and this equation becomes, now we have s raised to 5 and inverse Laplace transform of 1 upon s raised to n plus 1 is by reducing power by 1, we will get inverse Laplace transform of this e raised to 4t as it is, and inverse Laplace transform of s raised to 5 will be t raised to 4 upon 4. Is it correct? Yes. Why? Because we are just reducing the power of s raised to some n plus 1 by 1, we will get t raised to n, and n factorial, so we will get t raised to 4 upon 4 factorial. Correct? Now next, e raised to 2t will use us e raised to 2t and inverse Laplace transform of 5 upon s square plus 5 square will use us sin 5, and it is the required result for inverse Laplace transform of 1 upon s minus 4 bracket square plus 5 upon s minus 2 bracket square plus 5 square. Correct? What we have done here, since we have the binary operation addition here, addition and subtraction. So we can distribute this inverse Laplace transform to both expressions. So why we can do this? Because of the linearity property of inverse Laplace transform. By using linearity property for inverse Laplace transform, we can distribute inverse Laplace transform operator to both expressions. Correct? We have here inverse Laplace transform of C1 f1 of s plus C2 f2 of s. We got C1 outside of the inverse Laplace transform operator and inverse Laplace of f1 of s. C2 is inverse Laplace C2 into an inverse Laplace transform of f2 of s. Correct? And where C1 and C2 are constant, so we have 1 as constant and 5 as constant. We can take it outside, but here we need this 5 to make this inverse Laplace transform A upon s square plus a square, or we can write it as also if or inverse Laplace transform of 1 upon s square plus a square equals to sine a upon. Correct? Now by using these linearity property, we distribute operator to both expressions, and by using force shifting theorem, we use this to say e raised to 4t inverse Laplace transform 1 upon s raised to 4 and e raised to 2t inverse Laplace transform of 5 over s square plus 5 square. Correct? Now, using this basic formula of inverse Laplace transform, we can deduce the result of this function. So today we will stop at this point. We have completed our first example based on inverse Laplace transform. In next lecture we will try to solve more examples which are based on inverse Laplace transform. So in next lecture we will see some more advanced level example, and I think it is quite easy, but you must remember all the basic formulas which are based upon Laplace transform, inverse Laplace transform, and on beta and gamma function. Now we will stop here. In next lecture we will see some more examples. Till then, thank you. Bye.